Today we're going to talk about alcohols and carboxylic or organic acids. Now we've dealt with both of these types of compounds before in our discussion. We're just going to learn a little bit more about their structure today. In this first example, let's start out with our alcohols. Alcohols, remember, are carbon-containing compounds that have an OH or hydroxyl group on the structure somewhere. So these are just some examples. This one is methanol. This first one is methanol. Old name was methyl alcohol. The next one is ethanol because it has the hydroxide is on a 2-carbon compound. So ethyl alcohol was the old name for it. 1-propanol, it's called propanol, first of all, because it's got 3 carbons. And then the alcohol, the OH group, is on the 1 carbon. We always start numbering from the closest carbon to the hydroxyl group. And so this is propyl alcohol. If the hydroxide were on the 2nd carbon, the middle carbon, then we would call it 2-propanol. This is familiar to you, I'm sure, as isopropyl alcohol, the stuff we put on cuts and disinfectant and things like that. So those are just some examples of those alcohols. Now, when we start naming them, actually, we're probably not going to get into anything that's a diol or a triol. It's not a hard thing to understand. Having an OH group in 2 places means you have a diol. Having an OH group in 3 places means you have a triol. But AP is, I would be shocked if AP went that deeply into the nomenclature of alcohol. So let's stick with just 1 hydroxide. So if we name these compounds, look at this first one, we've actually, well, I'll just go ahead and number it. The longest carbon chain is the one that's up and down. So looks like the hydroxide is in the middle. So there's 1, 2, and 3. So here's our CH3 group. Here's our hydroxyl group. So it looks like we've got 2-methyl, because that's where the methyl group is. Two methyl. And then since it's the hydroxides on the 2 carbon, it's 2-propanol. 2-methyl, 2-propanol. On the next one, if we start numbering closest to the hydroxide or the hydroxyl compound, we would be numbering it this way. And looks like we've got a methyl group on the 3rd compound. So this looks like it's going to be 3, I said 3rd compound, I meant 3rd carbon. 3-methyl, 1-butanol. Since it's a 4-carbon compound, my B got a little carried away there. 3-methyl, 1-butanol. So that's how we would name that one. And let's draw one. Okay, first of all, it's 2-heptanol. So let's draw our 7 carbons. And it's 2-heptanol, so it looks like the OH group is on the 2nd carbon. 3,3-dimethyl, looks like we've got a methyl group twice on that 3rd carbon. So we've got 2 methyl groups on the 3rd carbon. We've got an ethyl group on the 4th carbon. I could write it out or I can write it up. Either way will work. So there's the ethyl group. And now I need to just fill in my carbons. Looks like I need 3 on the end as I normally do. Only 1 here because it already had 3. The next carbon doesn't need any. It already has 4 pairs of electrons around it. This one needs 1 to make its 4th. This carbon needs 2. This one needs 2. And this final one, as usual, needs 3. So that's how we draw the alcohols. Now, as far as the carboxylic acids, we're not going to get into a bunch as far as nomenclature is concerned, but I do want you to see where they get the names. We are very familiar with this one. We have used and worked with acetic acid many, many times. And if you drew the structure or wrote the structure like we normally write it, we would write it like this. That COOH on the end, when you draw the structure, however, ends up looking like this, a C double bond O with an OH on the end. We covered this in an earlier set of notes in just recognizing the compound. More and more on the AP test, though, they're naming it by its IUPAC accepted nomenclature. So the International Union of Pure and Applied Chemistry, I believe, is what that stands for. And it's called ethanoic acid because it has 2 carbons. Formic acid, we see written as HCOOH many times. Formic acid, they usually call on the AP test now methanoic acid because it only has 1 carbon. Propanoic acid, there's a couple of ways that you'll see it written. It could be written CH3CH2 COOH, or you might see it written as C2H5 COOH. So there are a couple of different ways these might be shown. Butanoic acid, same situation. They all have that C double bond OOH at the end, but this one they might show you as this. Just hexanoic acid, there's no telling what they might give you for the formula. They all do the same thing. Every single one of them does what acetic acid does, and that last hydrogen on the C double bond OOH part is the one that is acidic. That's the one that comes off when it's acting like an acid. So this one might be written as C3H7 COOH. So those are just some examples of some carboxylic or organic acid. There are lots of different kinds, way more complex than these, but these are the main ones that you might see on the AP test.